and welcome to my talk. Now we're going to paint the promises that Dmitrii made about actually showing you what vHive can do, and how the next generation of this very interesting kind of architectures could look like. If you have any questions on the process, please interrupt me anytime. And please also open the README that we provide online on the tutorial. If you want to follow along, I have all the commands in the README, so you don't need to copy them from the slides. So first, what does serverless mean for researchers? So basically, we need to, serverless has made a bunch of promises, right, for this very special division of labor that Dmitrii showed you earlier. So the cloud providers promise to take care of all the infrastructure, all the hardware, all the lower level software stacks, and the users only need to provide their functions, and we'll just take care, the providers will take care of everything else. So this is very nice. If you're the user, this might open up a bunch of questions if you're the provider, right? But this is also nice because it also opens up a bunch of questions for researchers that we can start to fiddle around with and try to figure out. So with the responsibility that we gained from becoming a provider, basically, we also have a lot of freedom, right? Because we can now design the entire stack from the function execution down into the hardware with new methods of isolation like MicroVMs, containers, hypervisors, and also think about what kind of runtimes that we want to use. And now in this talk, I'm going to show you how you can use vHive to use, for example, different kinds of function types and experiment with them and see how they behave and how to go through the entire execution stack to see where, for example, you lose time. So this is the agenda. First, I will show you how to set up a very simple node for vHive. We will have a single node setup. So we will run the master and the worker on one node. Then we will measure some end-to-end latencies for different kinds of function containers. And then I will show you how you can trace the execution of a chained function through our stack. All right, so first, each one of you should have gotten a VM, and you should be able to log into it with SSH. Please note that you should add the port forwarding that I added to the SSH command. And this will be used later to access the UI for the actual tracing. So just to make it easy, so you can look at your local browser instead of doing anything else. So all the commands that you will see in like this special font, they should be in the README, so you can just copy them out there. Also, if you have any trouble, we can just SSH into your machines. But to see what you have been doing, it would be useful if you use tmux for your sessions, so we can just attach to your sessions and actually check what you've done already, which makes it a bit easier to debug. All right. Then, so first I'll have a quick look again at how Firecracker looks like. So this should be somewhat familiar to you. You can see that on one worker, so in the middle of the graph, you have the vHive CRI, which is the container runtime interface, which manages the worker. The CRI is basically a unified interface for the control plane to interact with. So the different container runtimes don't need to all adhere to the same specification, but the CRI will bridge this. In our example that we go through, we will bring up a process using Firecracker, container D for the functions, and standard container D for all the infrastructure code. So all the Kubernetes and the Knative parts will run in containers, and the actual function executions will use Firecracker. Now let's go through a simple example, and I'll show you how to set this up. So first, we need to prepare the node. We have quite an easy script that will install all the necessary things. On the VMs you have, this should go somewhat quickly since we pre-installed most of the things you will need. So maybe Hongyu can let me know, or someone who's following along can let me know when this step is finished.
Tom, there is a message saying there is an error, fatal destination pass, home vHive client already exists.
Yes, there's some expected errors. I put them into the README. You can see there that what the expected error messages are, and all those that I've listed there, you can just safely ignore. Yes.
I think this step has already been baked into your production machine, so they're going to do that.
Yes, but also there's some runtime parts that need to be reinitialized. So did it work for those who tried?
Yes.
All right, perfect. So now we have the general setup for our work done, and we can go on with the next step. So to run our infrastructure code, we will need containerd. For this, we can start it in the background using screen. This will just basically open a separate session and run containerd in the background. Then after this, we need to start a Firecracker containerd. It's a bit more complicated, but you can just copy paste the command. This will start the environment so we can later on run our functions within Firecracker. If you've done this, you can check that both of them are still running using sudo screen -ls. There should be a command in the README, and you should see two screens, one called Firecracker, one called containerd, and they should be running. Then once Firecracker and containerd are running, we can also start vHive. We can also start it in the background with pretty much the same command, and then check again that all of them are still running. So now we've started up everything that should be running on our worker. So now we need to start up all the infrastructure. This includes Kubernetes, Istio, and Knative. Since this is quite cumbersome, we also provide a script for you to do it, which is quite easy since we're on a single node. You can just use one script. It's this command, and this will take a few minutes because it needs to first start up the Kubernetes and then all the other components and properly connect it and make sure that it's. So maybe, we can also check in the Slack. And when a reasonable amount of people have completed this step, we can start actually using it. So the nice thing about this, this is a very quick workflow. It takes a while to execute, but the effort on your end should be quite low, which is one of the nice things about using vHive, that we already have scripts for single node setups. We also have scripts for multi-node setups. So in case any of you later want to try it out, there's also a very comprehensive guide on how to set up these clusters with multiple workers that also require quite low effort on your end.
Hi, Tom. While we wait for the scripts to complete, would it be possible for you to give some details about the changes made in containerd and Firecracker containerd?
You want some? Yeah, sure. So you want some details about the difference between Firecracker containerd and containerd. Do I understand this correctly?
No, basically the changes that were made for vHive to run in containerd as well as Firecracker containerd.
Okay. Yeah. So maybe Dmitrii will be more. Would be better suited to answer this specific.
Sure,
question.
sure. No hurry. I was just saying if as we are waiting and if it's a good time to answer. Otherwise, it's okay. I mean,
I think Dmitrii should be still around, so maybe he can answer it now.
Yeah, I can take a question this. So the thing is that containerd implements CRI interface, container runtime interface, which is a contract between Kubernetes as a cluster scheduler and containerd, which is basically implements these commands in the runtime, such as container runtime or MicroVM runtime and so on. So the thing is with MicroVMs have limited capabilities compared to containers. For example, Firecracker does not support mounting arbitrary volumes like virtual disks into Firecracker as a container would support. So we had a choice of either hacking containerd for assuming only limited support for certain containers, or actually replicate part of the control plane as a lean piece of code so that we keep MicroVM specific containerd code separately. And actually, we were not the first to do so. The Firecracker team started this effort. We just keep evolving it. For example, we added snapshots. And this is easier to maintain than a single containerd. So I think if it's answers the questions, I think, Tom, you can continue with no more people waiting.
All right, perfect. So now that we have sorry. Okay, I misheard. So now that we have this, we can check that everything started up correctly. You can do this with kube control. This is the standard Kubernetes interface. Some of you might already know it. So you should see a bunch of different containers running, specifically Knative eventing and serving, and also, of course, the Istio, the kube system, and the others that we need for the infrastructure. If there are any of these that are in error state, there's a cleanup command at the very end, and you should probably contact Hongyu to see if you need to, or contact us, any of us on Slack, so we can see if you need to restart your machine. Sometimes the containers don't come up correctly, and the easiest way to fix it is just to restart the script. But yeah, this should not happen, but just in case we have some stragglers. All right. So now that we have seen how to bring up this cluster, we also want to use it for something. And for that, vHive also provides you with some nice tooling, which are the deployer and the invoker. So the deployer is a automatic deployment tool, which will take a list of functions and a few parameters, and then automatically deploy their configurations to your system. It can also deploy to other systems, but we use it to deploy to a local cluster for now. It will then output a file with all the endpoints from the functions that it generated, which we can feed into the invoker, which will then go through all the endpoints and invoke with certain patterns. For example, we can tell it how many requests per second we want to issue or for how long we want to run our experiment. This is interesting, for example, if you want to see warm invocations, you will need to run a experiment that is a bit longer to make sure that you're using the warm containers and you're not getting cold starts with like somewhat mild requests per second. If you want to see a lot of cold starts, you can just run a very short experiment with a lot of RPS, which will ensure that you have a lot of cold starts at the beginning. What we will do now is first you just deploy a single function. It's basically just a hello world that enters and then returns almost instantly. You can deploy it with this very easy function and then see that it's actually deployed by asking Knative to list all its services. So
there is one error reported. Default domain is in the error state. I guess default domain pod.
Okay.
So I guess we need to restart the cluster, right?
Yes, for that specific one. Then it's yes, then one of the containers didn't start properly. So you can use the cleanup that is given at the very bottom of the README. And you can start again from the top. Or not from the top, from the part where I actually set into the tutorial. So where we went into vHive and did the node setup. Okay. You don't need to clone the repositories again.
From the single node to the part. Okay, yeah, I get it.
Okay.
Yeah.
Yes, for setup nodes, exactly. Okay. Yeah, for everyone where it worked, they should now see a single service deployed that's called Hello World 01. And then they can use the invoker with, for example, 1 request per second for 10 seconds. You can use any other combination. Depending on how you do it, you might get some interesting results. I would advise you not to use too high requests per second, because some of the infrastructure on a single node is just not made to handle 1,000 requests. So you might want to stick with something that is similar to what I give you. And then you should see an output in a file that's called RPS 1.0, or how many RPS you set, and then single function appended to its end. You can check into that file and you will see a bunch of numbers. This is basically just a very simple list of latencies. So the very first number will be the latency for the very first request, and then so on. This is basically not made for you to analyze by hand, but to feed into other analytic tools and to do statistical analysis on. But still, you can like have a look at it and see if you can find something interesting. For example, what you should observe is that if your, let's say 10 seconds, 10 invocations ran through, the first invocation should have a very much longer latency than the later ones, since they will experience cold starts, and the later requests should see warm starts, since there were already requests that were finished. So then, since a single function is not very interesting, and we want to demonstrate what we actually could potentially do with these tools, we will also show you how to deploy multiple functions at once. So this is done using this multifunction feature of the deployer, which basically allows us to just tell it to deploy the same function under 3 different names. So it will deploy hello world as 3 different functions. This is useful if you want to, for example, study cold starts. You don't want to wait until a single actual function is evicted, but you can just deploy the same function 10 times, and then you will be able to see cold starts more frequently. In addition to it, we also deploy one function running AES. So this is implemented in Python. This should give you, for the warm starts, an idea of how much, like that some functions will run longer than others, and will also show a different pattern of runtimes in your invocations. So as before, you can deploy it and then check that you have 4 services listed by Knative. It should be hello world 1, 2, and 3, or 0, 1, and 2. And then, of course, the Python AES. The invoker will read the endpoint file and then go through it round robin. And so you would expect for it to call first the 3 hello worlds, and then 1 call to the AES function, and then start again with the hello world. So in this command that I give you as an example, you see 4 calls per second, 10 times, which means that you have always 3 times hello world, 1 times AES, and then repeat that. You can now have, again, a look at the pattern in your response. And you might see that there isn't such a clear pattern, especially in the beginning with the cold starts. Some of the hello worlds might be faster than AES. Some of them might actually be slower. It's not very telling how a single invocation works. Right? So again, I want to emphasize, this is data that might be interesting to look at, but the real gain from this comes when you run more experiments, longer experiments, and then aggregate this data over time. Now, I've showed you a lot about the simple setup, but you maybe want to compare the just normal Firecracker execution with something else. So for that, vHive allows us to switch the mode of operation. As Dmitrii already told you about, we support Firecracker and gVisor. We can also run on regular containers. For starting up functions, you have seen or should have seen the effects of cold starts in the latencies from the deployment we just did. But vHive also supports some snapshotting. So because the idea was to actually figure out what makes a system slow, they used vHive already to see that the cold starts are quite big. And they started to work on one possible fix, which is VM snapshotting. So they implemented snapshots for Firecracker, which is basically taking the working set and storing, pre-starting a VM, and storing the working set so that we can start it up faster. This is work that was already published also here at USPLOS. And to simply switch between the current cluster that you have and one that is using snapshots, you can export the snapshot environmental variable and then rerun our one node cluster. This will automatically tear down your entire cluster and then set up a new one that is using the snapshots. So this will again take a while. So yeah, I'll post another message to Slack so we can keep track. Yes.
So when I run the application, I found the real target APIs, right? You can we'll launch the application. You have some results. You have like a real target APIs.
Rail packet IPS. Wait, I'll take a look. Just 1 second. There was one question about this, yes, this real and the target RPS. So you could give the script the command to say, okay, I want to run at 100 RPS, right? But when it tries to issue 100 requests in a single second, the cluster might not be able to keep up.
Yeah,
right?
So you mean the real is being like lower than target?
Yes.
Okay.
So
but here it's already also always 100, right? It's because the request is very slow.
Yes, we use a fairly low request rate so that we will get an answer for every request in time, that we don't have timeouts. If you have a higher request rate, you might see timeouts. Also, even with this low request rate, I think, yeah, there was someone in the chat that has a 0 requests per second. This can happen if the system doesn't scale up in time for you to get responses. You will actually experience 0 actual RPS. So you didn't get any responses within time before the script just disregarded the request. In that case, you can try to rerun it. Often on the second or third run, you will just get the responses you would expect. But this shows just that the infrastructure that we currently have is not very, very fast, right? Because we have somewhat aggressively set the timeouts for the script because we didn't want to wait for 10 minutes until all the requests finish. So we have a somewhat aggressive timeouts, and sometimes the system doesn't start up the containers fast enough. So then you might see less actual requests per second than you targeted. But with multiple runs of the experiment, you will see if this is a general problem. So for example, if you have 10,000 requests per second, a single node will just never keep up. But if you only have one, then if you repeat the experiment a few times, you will see that it's only on the first time or the first few times, and later on it will be able to keep up. How can you configure the timeouts? You would need to go a bit into the code for these timeouts. So they're not, I think they're not one of the easy to configure parameters. Also, some of them are timed out within the sorry, I lost my train of thought. Yeah, sometimes the timeout is not only done by the measurement. Sometimes also you get a timeout response from Knative. So these would be configured in Knative, not in our part. Okay. So some people are still waiting. Some people are actually running the snapshot cluster already. Okay, so there's 2 people still waiting for a cluster. We'll wait for those 2 and then continue onwards. I mean, the others can already start redeploying. Basically, you deploy the 2 functions again. If you, this should work the same way as before, because the deployment mechanism is just reused. So there's no difference in deploying and invoking, no matter what kind of runtime you use. So let's see. Okay. Looks like people are more or less done with starting the second part of the cluster. So now we can again check that all the services are listed. So you should see again 4 services, the 3 Hello World versions, and the one doing AES. And then you can invoke. You should notice that the last argument of the script is a name that it appends to the RPS. And I appended snapshots so you can actually differentiate between the 2 files. So you can get different traces and then can look at them separately or compare them if you want to. And what you should see there is that the startup times will be a bit longer in the initial startups, because we don't only need to start up a new machine, we also need to snapshot it. So this makes the very first cold starts a bit slower, but all the consecutive starts will be faster because we can start them from a snapshot instead of start booting them from the VM image. Right. So you should see that the times are in the beginning a bit fast, a bit longer than the original version, but then become faster than it. But I will not chase you into a lot of CSV checking, because there's a nicer way to actually have a look at these times, which we will go into next. So are there any specific questions up until here?
Oh, I got a question. Do you know,
Yes.
Tom, if Amazon or Google are using snapshots or are supporting snapshots right now or not?
So from as far as I know, Amazon is considering them, but they're not yet using it. What they're doing to speed up the startup is basically keeping a warm virtual machine that is not configured to any specific task, and then inject the code. But as far as I know, they're also looking into snapshotting, but they want to do more thorough testing for security reasons, because there might be some problems with starting from a snapshot that you might leak some information that you don't want.
Thank you.
You're welcome. Yeah, if there are no other questions, we'll go on to the second part. So you've seen.
I have a question.
Sure.
So I understood that snapshot means this, the snapshot of the VM itself, but I didn't get it in the context of function as a service, because the deployed part is just the application code. So the whole VM state, how does that play into this, like for the end user, it's just the application code. So how would saving the whole VM state help with anything?
Yes, so there basically the problem is that the current providers start a new VM for your applications, as Dmitrii explained to you.
Yeah.
And this is more a problem on their part than the application, right? So the application wouldn't care for starting up the VM, but since the provider needs to start up these VMs very regularly, or they are very interested in how to do this startup very fast. And also because you need to assemble the VM sometimes, right? You need to inject the code into it. And there's also the VM on startup needs to do some work, right? It needs to initialize its internal state. And you basically want to skip this initialization of the VM internal state. To speed it up.
Got it. Yeah. So there are certain, you could say, compilation steps for the function to start running, and those get saved in the snapshot. So those don't have to be replayed. Got it.
Yeah. Also, if you want more information on the snapshotting process, there are quite a bunch of papers. One of them is from Dmitrii, so he probably has the link ready to share with you, where they can go into more length about how this is actually useful to the provider and also to this specific function.
That would be very helpful. Can you share it on Slack?
Yeah, I'm sure.
Dmitrii or whoever, whenever possible.
Yeah, if it isn't shared by the end of my talk, I'll send you the link. All right. So any more questions? Okay.
Yeah, just one thing. So when I started this vHive with this snapshot argument, I'm not able to deploy the function. I mean, is it just me, or is it working for everyone else?
Okay, so deployment doesn't work on the second start.
No, so I'm trying this snapshot variant, which you have just mentioned.
Yeah.
And I'm trying to deploy again as it's given in the blog, and it just it's hung there. I had to like control C the command, and when I see the key and service list, it just says revision missing for the image, I believe.
Yeah. Yeah, I can check in with you later. Did anyone else experience this? Because this is like the first time I'm running experiment with more than 5 people trying this. So we might find something new here, but I did extensive testing and I haven't seen this before, but I will check in with you later, or maybe someone else can in the meantime see if there's an issue. Maybe it's also an issue with the virtual machine we assigned you. But yeah,
no problem. Yeah, no problem.
Perfect. So yeah, so we want to go away from just looking at raw latencies for single invocations, because end-to-end latency in the end doesn't tell us what's actually happening, right? So we could have a latency of 5 seconds for a simple hello world, but it doesn't tell us how these 5 seconds are spent, right? And for that, we want to reintroduce the OpenTelemetry and Zipkin. So Dmitrii already told you about OpenTelemetry. It's a set of APIs and SDKs and tooling to create and manage telemetry data. For example, traces, metrics, and logs. And the project is aimed at being vendor agnostic so that it can be used with different kinds of backends and also used with different kinds of languages, etc. And for that, we mainly care about these traces. An example of which you see on the right side, where you can see all the services and then the tree of how the latency was spent. So a bit of terminology: a trace is a progression of a single request and how it goes through the entire stack. Each stop basically on this request's journey is a one span. So if the span is a time that it spends in a very specific service, which will include services that are called by this service. So if you have a chain service, then the span for the topmost service will include the time that is spent by all services that it calls until it returns to the original top service, which then returns to the user. So this will kind of give us a tree of these spans, which we can then assemble into what is the final trace. Also, vSwarm already gives you support for Python and Go, which is very easy to use. And I'll show you a bit later. But the OpenTelemetry in general also has support for C++, Java, JavaScript, and other languages like Rust. So how does this look like in our specific server? Is we use Zipkin as a backend. So Zipkin will provide us with a UI and a collector endpoint. And we have instrumented our code, and like a lot of protocols are already instrumented, to automatically, if you give them an endpoint, send this span information to the endpoint, and the endpoint will then assemble the traces out of this span information. And we can then simply go and look at the UI and do the click-through instead of looking at a bunch of CSV files and doing statistical analysis. So how does this instrumentation work? You can see here an example of Python code that we have instrumented. We only needed to start the tracing, which is the very top part. And then you can see in this with clause, we say that this is the tracing span. So it will send a single notification to the Zipkin when we enter this with statement. And when we exit it, it will send a second notification that this span is now over, which can then be assembled back into the total span and then integrated into the bigger trace. Zipkin also runs directly in our infrastructure code, which works quite nicely with all the remaining parts. So what is the thing that we want to trace? I'll go back and use video streaming that is already in vSwarm integrated. It has 3 steps. First, it accepts the video, it streams it to a decoder function, and then does object recognition on single frames. The number of frames is configurable, so we can have a single frame or we can have a multitude of frames. And the transfer uses S3 buckets, so because there's no, you can't pass big payloads directly through functions. So each function will upload to S3, and then the next function will download again. So what the actual application developer would need to do is only write these 3 functions, and then all the communication, etc., would be taken care of by the provider. So to set this up, we will use stock knative. So basically stock only vHive. This is mainly because it's easy to go through all steps. So we're not stuck in going through a bunch of vHive and then back to knative and then back to vHive. So we will use a very simplified model. And for this, you can use the following commands to set it up. An important reminder again, to use SSH with port forwarding, so you will actually be able to look at the user interface in the end. If you don't see a user interface, it might be because you have forgotten this port forwarding part in your SSH. So yeah, this again will take a bit of time. And if there are any questions up to here, feel free to use the time.
Hey, can you hear me?
Yes, I can hear you.
So can vHive run any function if as long as I can create a container out of it? Like any language. Basically, I wanted to just so let's say I have like a language like let's say Rust, or let's say hardware language like Verilog, right? And if I, or like let's say some CUDA, let's say, yeah, let's say CUDA to launch on a GPU. So basically, right? So if I create a cluster so container for my program application, and if I launch it on, like, let's say one of these pods, will vHive support it?
I'm pretty sure that we currently only support CPU containers, but it seems Dmitrii also has an opinion on this.
Yeah, Tom is right. So let me take this question. With the user runtimes that runs on CPU, we support anything that Linux can run. But you need to be careful with the hardware. As of now, there is only 2 virtual devices emulated, the NIC and if we are talking about Firecracker particularly, the NIC and the disk. That's it. When we talk about specialized hardware like GPUs, so I wouldn't give you a recipe, but I can say that Kubernetes does support, does have experimental support for GPUs, which means Knative running on in the stock only mode with containers may be quite easily ported to do so, but it's an experimental feature. So at least it gives you a starting point. Yeah.
See.
I'll quickly get myself some water. Be right back. Okay, so there's a question in Slack. Can vHive be used for any existing Kubernetes-based cluster, which may be using Docker containers underneath? Asking this is as previously it was mentioned that vHive needs containerd and Firecracker to be modified. So the cluster that you're starting right now is Kubernetes only, so it doesn't use Firecracker. And you can start it with only normal containers. You don't need to use Firecracker containers. So it's not depending on the Firecracker container.
And I can also add that Firecracker modifications is our accelerator design of their snapshots. So you can use it with vanilla Firecracker if you need to as well.
Okay, we'll wait a bit more for those still setting up, and then I will show you what to expect now. So maybe I can already show you, like remind you of what Dmitrii already showed you. So you can start to think about what we are expecting from the next steps. So this diagram should be familiar to you, as Dmitrii already showed it. It's a very high-level overview of how Kubernetes works. And since we're using stock only vHive, this is basically what we're running on right now. So when your function requests come in, you're expecting it to go through the activator and then the queue proxy and then into your function. So far, this is not very special. What now for our use case, we will want to chain 3 functions after each other, right? So there will be a first stage that will send a request to the second stage, and then the second stage will send 1 or more requests to the third stage. So each of these stages will again need to go through the ingress, the activator, the queue proxy, and then into the function. So this is just to remind you that what kind of components we are expecting to show up in the trace. So, okay, now it seems everyone is caught up. So we can deploy this video analysis framework. For this, you first need to put your AWS credentials as variables onto the server. So you're supposed to insert the key and the secret that we gave you at this part. And then you will also need to create a bucket because we need to transfer data through S3. So all these commands are still in the README file, so you should be able to follow along. I'm not sure if you can use the same bucket that you created before, but maybe that would be nice if you can reuse them. Let me.
No, I think you have this link I posted. So try to click again and create a bucket essentially.
I think I'll just give you a few minutes. You already did this before, so, and it should be quite self-explanatory from the Jupyter notebook.
I got a question. So
Yes.
I see the export bucket name equal to hash. Like what's the hash of what's the bucket name here? The hash
The bucket name should be given to you by the notebook. So
in the setting up identifier, there I can get a hash.
I think you should set your own name in the, wait, let me open this, I guess. Yes, you should give your bucket a name. Here, this hash. And that's what you should use as your bucket name.
So if you go to the step setting up identifier, like the previous one, this hash is computed based on the first name, last name you insert. So it has to be unique for participants to use their unique buckets. So this is the only part you need to modify.
Okay, so for example, after I executed this one, I got a hash equals to some number, and
yes,
so I put this number as the bucket name, right?
Yes,
okay.
Exactly. You put this number that you get as bucket name. Right. To those online, still see my window? I guess so. All right, I think most people are now finishing with bucket creation, so we can continue on. So the next step, of course, after we've created this bucket, we will deploy some functions. And before we just go on deploying, while the last of you are finishing bucket creation, I will show you how these functions are defined. So this is a part of the specs of the function that we will deploy. Specifically, this is from the function that splits. So it's a decoder. Is it readable in the room? Okay. This specifically is from the decoder function. So it will take in the video stream from the first function and then split it into multiple frames for the recognition later on. You can see that this is where we also pass on the secrets and the bucket name that we need within the task. And also we can modify the number of frames. So the decoder frames value, we can either pass on one frame or we can pass on multiple frames. And then also enable or disable tracing at this point. This can be directly used. So this can be directly used to deploy. So the bottommost command will automatically deploy all three functions to your cluster. And then you can again list all the services using knative. And you should see three services. So one should be streaming, one should be decoding, and one should be recognizing. Then the streaming is basically the first function you need to invoke, which will then pass on data to the other functions. So you will need its host name, which is the address that you get when listing the services, minus the HTTPS and the front. You can use a test client that is provided by vSwarm to issue a single invocation to this service, which you will get back a list of objects if it successfully executes. So this is the command in the middle of the screen that you can see now. You should replace port with 80, which is already done in the README, and then the host name should be the service address that you get from the KN service list. And after you got this list back, you should be able to go to your local browser, localhost port 9411, and see the Zipkin UI. And how this can look like, I will show you right now. So you should get a window that looks something similar to this, maybe minus the graphical glitches, hopefully minus the graphical glitches, where you can see one such execution queue. But first you need to search for it. For this, you can click to this Discover page. Here, select service name. And then from all the services you could search for, we want to search for recognition, because we want to see a request that has went through all the way to the recognition service, right? So this means that any trace that we see here comes from invocations that went through the streaming, the decoding, and then to the recognition. Once you have added this filter, you can click on search all the way on the right, and then you should get one request that looks something similar to what I have here. Then you can click on it, and you will see a very nicely detailed trace, right? So to go through it again, we were expecting to go through the activator into the first queue, then to the first service, and then repeat this for the second and third service. So you can see here that we are in the activator for the first service. Then we go through deployment, the activator service, and then into this first one. You can see that we do this video upload. So this is where the streaming uploads the video onto S3. Then we again go through the activator service because our first function calls on the second function. This activator service will deploy the second function and start the decoder. So in here, the decoder fetches the video from S3, decodes the frames, and then uploads the frames to S3 so we can pass it on to recognition. And for the files I prepared for you, I made it so that it only passes on a single file, so we can easily follow this with another layer of activation and deployment, and then the actual recognition. You can see here that the spans for the actual service in the decoder go all the way to the end until inference in recognition is finished. This is because the recognition is the decoder is still waiting on an answer and running, waiting for this answer, and only once it gets the answer, it will finish, return back to our original service, which will return back to the user. So this can be very nicely used to identify different things that we spend time on. For example, you can see that in this throttler, we use only 9 microseconds. And then the activator proxy, which includes the entire execution plus some overhead, uses more than 1 second. And the difference between this activator proxy and our actual function running is the overhead. So this is 0.02 seconds. That is the time between arriving of the request at the activator queue proxy and the actual function execution. So this is how you can go through even big chained kind of function execution and figure out where you spend time, which parts you might want to optimize, which parts you might want to make parallel, etc. To show you how this can be a bit more, how this can look in a bit more complicated cases, we can remove.
There is
Yes.
there is some mistakes report or errors reported in Slack. Can you just take a look, maybe comment on them?
Yes. It doesn't show up in Slack. Wait, for me. Okay. Yes. So I previously asked you to check if all the, so after setting up your cluster, you should check if all the containers actually are up. We did this also for the Firecracker. I was pretty sure I also put it into the manual to do it here. So it's also like the waiting for the containers to start. You should check that all pods are actually running. This error usually comes up when not all pods are running. So there might be some issues with the infrastructure having pods that are not properly running, which will then not relay your function, your request to your function. So you won't get any answer. All containers are up. These pods are not running. Yes, these pods should be running. Wait, is this? Yes, so you have a bunch of error. So you can use the cleanup script again at the end of the README. And then I would also recommend to basically just start again with the basic script to set it up. So at the point of where we started with the tracing. So basically at the thing I'm just showing on the slides. Additionally, you could also, after rebooting the VM. Okay, I've never seen it after rebooting. Okay, so there's some issue with the VM, then I would suspect if it's either after rebooting the VM. But yeah, we'll have to, it will be nice if you can leave that VM running so you can check it later. And maybe Hongyu can give you a different VM. Because the VMs should get all the pods running. But yeah, we will investigate it. Thank you. So yeah, maybe I'll show you the final case that I wanted to make. So basically what we changed in the second deployment for those that can't do it themselves is we can use the same code, but deploy it to pass on 6 different frames to the recognition task. which will then result in a trace looking like this. So you can see still the activator service up until the decoder being exactly the same as before, but the recognition, you can see how it calls to the decoder and then recognition calls multiple times, and how each of them you can follow how they go through the system to their part of the recognition and then start the next frame. So this is a total of 6 frames, which starts with the decoder passing on 1 frame, recognizing a 2nd frame, a 3rd, and so on. So you can very nicely follow this path all the way through these 6 frames. So you can also do this if the 6 frames are not processed after each other, but processed in parallel, or you could also add additional functions. So for example, if you want if the decoder wanted to pass on these frames to other things after it got the recognition, for example, depending on your recognition, you pass it on to another service that maybe stores it into your database. This you could also instrument and add to these traces. All right, let's look if there's still any errors in Slack that I need to address.
I think it's probably fine. You can wrap up, and we'll leave a few minutes. Actually, we have a break for half an hour, so we can still spend time on debugging.
Yeah, so what you should take away from this tutorial is that you did a lot of hard work. And I got to just stand here and watch you, which was very nice. And that there is a lot of opportunities for actual cross-stack optimization. Like you've seen that the stack is very high or very tall, and there's a lot of dependencies in this stack that we still need to look into, how they interact with each other, how we can make this a bit tighter. We also showed you how you can use vSwarm and its built-in OpenTelemetry support to actually trace through all the layers of these stacks to find interesting behavior in a nice visualized way without crawling just through stacks of numbers. And also how vHive and vSwarm help you do research on these very distributed tasks, right? So this would work exactly the same if with a cluster that is running on 100 nodes than it did with this one single node. So yeah, we encourage you to use our platform, and of course, maybe help us out a bit. And if you do anything cool, maybe upstream it. But yeah, that's for me for today. You will have a short break, and then you will get to relax a bit more, as Lazar will do all the work for you in the next tutorial.